let's see. We want to solve this system of equations. And I'm going to try to eliminate, it says elimination, right? So I want to eliminate these and this. See how it makes a little triangle in the lower left corner?
Okay.
So I'm going to try to eliminate. I'm going to go in order. I'm going to eliminate the 4 first. I'll start here. Then I'll eliminate the -5. And then I'll eliminate the y. So I'm going to follow that order.
Okay.
Specific order, okay? So let's see. Now, in order to eliminate the 4, what I'm gonna do is multiply the top equation by, do you remember?
To eliminate the 4, we're by the second row?
Yeah, to eliminate that 4, what do I need to multiply the first equation by?
First equation by...
In order to eliminate this x. To eliminate this x right here, I need to multiply this by something.
-4.
There you go, -4. So I'm gonna do that, watch. So I'm gonna say -4 times x plus y plus z equals 4. Okay, does that make sense? Why we're doing that?
Yes, because we're trying to make the top row negative to eliminate the 4 in the second row.
Exactly. So watch, this is gonna become -4x minus 4y minus z of minus 4z, right? Equals to what? -16?
Yes.
All right, now I want to copy the second row and put it right beneath it so that I can eliminate. So I'm going to do this. I'm going to say 4x plus 3y plus 2z equals to what? 4 times 4 is 16. Okay, so wait, why did I multiply that times 4? My bad. I'm going to leave this as 4.
Okay.
We all make mistakes. So now what I'm going to do is I'm going to add these 2 equations. So I'll use like an orange and I'll just like, boom, copy those. I cancel those out. I cancel the x's and I just add things. So I'm going to get what? -y minus 2z equals to what? -12?
Yes.
Now, here, okay, good. So that's good. That's my new second row. Think of that as your new row 2. Think of originally that there's 3 equations or 3 rows. Now that's my new second row.
So now there's no longer that x plus y plus z equals 4.
No, I'm gonna leave that. That equation stays the whole time.
Okay.
The first row stays the same. The second row changed. This one changed, right?
Yeah.
This one also changed.
Okay.
But the first one stays the same. Now, I'm gonna move to the next step if you're good with that.
Sure, yes.
Next thing I wanna do is eliminate what number?
-5x.
How do I eliminate -5? What do I do?
So the second, if I'm looking at the new second row.
Ignore the new second row. I'm always gonna use the first row to eliminate the second and the third.
So if we want to eliminate that one, then we would multiply the first row by +5.
There you go. You see it. So I'm going to do 5 times x plus y plus z equals to what? 4. So this is going to give me what? 5x plus 5y plus equals to 20. Below that, what do I do below that equation?
We bring down, and then we do -5x plus y minus z equals 4.
Yes, good job. Okay, great. Now I'm going to use my orange color to cancel the x's, right? Then what do I get?
6y
Yeah.
plus 4z equals 24.
Yes. And now what I like to do whenever I get an equation that has all even numbers or a common factor in all 3, I just like to simplify that equation. So I want to make that equation, I want to divide both sides by 2 basically. So I'm going to kind of divide both sides by 2 and make this 3y plus 2z equals what, 12? And now none of those, I can't reduce that equation anymore. It's as simplified as possible.
Okay, that's where I kept getting stuck because I didn't know how to solve for y and or z
That's
without.
okay.
Yeah,
That's
I didn't know
okay.
if I was.
We haven't got there yet. We haven't got there yet, actually. We don't know how to solve for y and z yet. We're still kind of going along this process.
Okay.
Now I need to stop and think. I need to say, what do? I have two new equations and then one original, right? I have that original equation. But what I want to do with these two equations, these two new ones, I want to realize that x has been eliminated. And remember how earlier I told you I wanted to eliminate, now I want to move on, and now I'm actually going to eliminate this y.
Okay.
So the idea is first you eliminate x twice, 2 times, and then now you eliminate y once. And if you do that, you'll be left with just z equals something.
Okay.
That's kind of hard, right? So remember this, the number 1, 2, and then 3, right? So I've eliminated this x, I eliminated this x. Now I kind of want to start over here with the y. But I have new equations though. So I kind of lied. I have 2 new equations. So I want to eliminate one of these y's basically from the 2 new equations. So that's how I want you to think. I want you to just think, hey, I got this one equation right here. I got this one equation right here. And all you got to do is try to eliminate one of the y's.
Oh, okay. So could we then multiply the top equation by 3?
Yeah, that sounds like a great idea, actually. Very good idea. Let's do that. Let's take the top equation and let's do 3. Like you said, negative y minus 2z equals to negative 12. And what do we get? We get negative 3y, minus 6z equals to what? Negative 36. Okay. And then what do we do next?
And then we subtract 3y plus 2z equals 12.
Exactly. Yeah. Well, we add those together. So yeah, you're right. So just take that second equation, write it right below, kind of like doing it the way we did it before. Remember?
Mm-hmm.
This equals to 12. So what if I do that?
So
and I'm gonna add these together, and I'm gonna pull out my orange pen and cross these y's out.
Okay.
Because they cancel out. Because they add to 0, right?
Yep.
And then now I get my last equation. What is this last equation?
Negative 4z equals negative 24.
Okay, good. Now, okay, perfect.
And we would, to solve for z, we would divide both sides by negative 4.
Yeah, I want to do something real quick. I want to remind us where we were, how far we've gone. You see this top equation? I'm going to grab it real quick. So that was our first equation. Remember, that one stays the same. Remember I said it stays. So I'm going to grab it. I'm going to put it here. And I'm going to grab my, a second equation.
Mm-hmm.
Which one looks easier? Negative y, the top highlighted one or the bottom highlighted one? Which one would you rather keep?
The bottom one.
You like the bottom one? Okay, so I'm going to put the bottom one here like this. I'm going to say 3y. What was the bottom one again? It was 3y plus 2z.
Z equals 12.
Equals 12. Okay, and then I'm going to put my last equation, which we see it right there. It's negative 4z equals to negative 24, right? So that is our kind of, we did a little bit of work and we eliminated 3 different things, and this is like what we get. We get this, right?
Uh-huh.
Now with this, so we're kind of done with our first phase of the question. And now from here, it's easy sailing.
Mm-hmm.
It's easy sailing from here. But do you understand how we got to this stage of the problem?
Yes.
Okay, so yeah. Now from here, we just do something called backward substitution. Backward substitution is just kind of starting at the bottom and then working your way up.
Okay.
So we start at the bottom because that's the easiest one to deal with, right?
Mm-hmm.
All we got to do is divide both sides by 4. So we start at the bottom, negative 4z equals negative 24, right? So you divide both sides by negative 4.
Uh-huh.
And what do you get? You get z equals 6.
Oh, you're right. Yeah, 6. I was thinking times 3.
Yeah.
Z equals 6. Okay.
And now what we do is we now we move on to the to the second equation. We go up one each time. So we go to the second equation, we say 3y plus 2 times 6 equals to 12. So 6 was that number that we found earlier. So maybe we can make it a different color, because that's the number that we just found from the bottom equation. And now our goal is to find y. So what we do is we just solve this equation. So 3y plus 12 equals to 12, right? So what do you do now? You subtract 12 from both sides. And you get 3y equals to 0. And you divide both sides by 3. And you get y equals to what? 0? Okay, so far we got z equals 6 and we got y equals 0. Now we're doing backward substitution, so we're going to go to the very top equation now. This one.
So now we have z and y, so we can plug those two into the
so we'll say
x y plus z.
So x what? X plus what? 0?
Plus 0 plus 6 equals 4.
Equals what? 4?
Yeah.
Okay, so then now we subtract 6 from both sides, right? And what do we get? X equals what?
-2.
So now we're done. So we have we could say our ordered triple solution is actually -2, comma 0, comma what was z again? 6?
6.
So that's our ordered triple, x, y, z.
Okay.
And that's it.
0, 6. Perfect. Okay, thank you.
You're welcome.